Hi, welcome to this video revising Junior Certificate Coordinate Geometry. Firstly, we will look at finding the midpoint of 2 points. Suppose we have 2 points. A is the point -2, -2, and B is the point 1, 3. We want to find the midpoint between these 2 points. The midpoint of 2 points is halfway between the 2 points, denoted here by M on our red line. The midpoint is the average of the endpoints. To find the average of the x values, we add the 2 x values together. In this case, -2 plus 1. And then we divide them by 2 to find the average, which gives us -1/2. To find the endpoint, the average of the y values, again we add the y values, in this case -2 plus 3, and we divide by 2 to find the average, which in this case gives us 1/2. So the point represented by M is the point -1/2, 1/2. This is the midpoint of the 2 points -2, -2 and 1, 3. We can now derive a formula for the midpoint of 2 arbitrary points. So for example, in our previous example we had the point A -2, -2. Suppose we change this to the general point x1, y1. And point B was 1, 3 in the previous section. Suppose we change this to the general point x2, y2. As we said before, to find the midpoint of 2 points, we find the average of the endpoints. So to do this for the general points x1, y1 and x2, y2, we have the average of the x values, which is x1 plus x2 divided by 2. And the average of the y values, which is y1 plus y2 divided by 2. Or M is, in brackets, x1 plus x2 over 2, comma y1 plus y2 over 2. This formula can be found in our maths tables in the coordinate geometry section. Please record this formula in your notes. Okay, I want you to pause the video here and do this question. The question says find the midpoint M of the line joining 4 minus 3 to the point -1, 2. Welcome back. In this section we're going to look at finding the length of the line joining point A to point B. Suppose we have a point A -2, -2 and B 1, 3. We want to find the distance between these 2 points, and it's equal to the length of the line that joins these 2 points. In order to be able to do this, we're going to create a right angled triangle and use Pythagoras theorem. Firstly, we create the horizontal line. To find the length of this line is the difference between the 2 x values, 1 and -2. 1 minus -2 gives us a distance of 3 units. Next we construct the vertical line, and to find the length of this line, it's the difference of the y values. In this case 3 subtract -2, which gives a distance of 5 units. Using Pythagoras theorem, this gives us the length AB is equal to the square root of 3 squared plus 5 squared, which equals the square root of 34. This square root is called a surd. Now we're going to look at a formula for the length of the line joining 2 arbitrary points A and B. Again, suppose we have the point -2, -2, but instead of using this point we use the general point x1, y1. And our other point B was 1, 3. Again, we change this to the general point x2, y2. Again, we're going to create a right angled triangle. And firstly we construct the horizontal line. The length of this line is equal to the difference of the x values, x2 subtract x1. We then construct the vertical line. The length of this line is equal to the difference of the y values, y2 subtract y1. Using Pythagoras theorem, this gives us the formula for the length of the line AB as the square root of x2 subtract x1 to be squared plus y2 subtract y1 to be squared. This formula can be found in your maths tables in the coordinate geometry of the line section. Please record this formula in your notes copy. Press pause on this video and do this question. Find the length of the line joining the point A, 4 minus 3, to the point B, minus 1, 2. Welcome back. In this section, we're going to look at finding the slope, also known as the gradient of a line. In order to find the slope or gradient of a line, we have to find it using 2 points on the line. To do this, we can use a formula. We develop the formula by reminding ourselves about the meaning of the slope. For example, in order to find the slope of this line, we can use what's known as the rise over the run. Here we have the run, and up here we have the rise. The rise is 4 units up, the run is 2 units across. So the slope m is equal to 4 over 2, which simplifies to 2. This line has a slope of 2. In other words, that means for every 1 unit I go across on the x-axis, the line rises 2 units up on the y-axis. Suppose we wanted to find this using 2 points, the points 2, 3 and 0, minus 1. Well, the run would be represented by the difference in the x values, 2 minus 0, which is 2. And the rise would be represented by the difference in the y values, 3 minus negative 1, which gives us 4. That gives us 3 minus minus 1 over 2 minus 0, again, which is 4 over 2, or 2. Suppose we have the 2 arbitrary points, x1, y1, and x2, y2. We can now find a formula for the general slope of a line. The run, again, represented by the difference in the x values, x2 minus x1, and the rise represented by the difference in the y values, y2 minus y1. Putting this into a formula for the rise over the run, it gives us m, the slope, is equal to y2 minus y1 over x2 minus x1. This formula again can be found in your maths tables in the coordinate geometry of the line section. Record this formula into your notes copy. The slope of the straight line joining the points x1, y1 and x2, y2 is m equals y2 minus y1 all over x2 minus x1. To use this formula, we don't need a diagram. I want you to pause this video here and do this question. Find the slope of the straight line joining the points 0, minus 1 and 2, 3.